Hey class. So today, since Rhino Inside is having some licensing issues and IT, it seems has a solution, but we're still waiting on them to finalize it. Uh, I thought this would be a good time to at least introduce you guys to Dynamo, and allow you to explore it, to kind of get comfortable with the layout and how it works. I mean, it's very similar to Grasshopper in its basics functionality. But I find it a little bit less intuitive on how to use. It's not as user friendly as Grasshopper, but it still has the same functionality. I was able to utilize it within the profession. I did my entire thesis around it, so it's still a pretty valuable tool. I just think once Grasshopper gets fully integrated into Revit, I think it's going to become obsolete, and you'll just be able to use the one skill set of Grasshopper in both functionalities. So to get started, simple, just start a new project, and just go to a 3D view, really, just to start things off. Dynamo is integral within Revit now. It's moved away from being a plugin, and they just integrated it with the base platform. So if you go to the Manage tab underneath your toolbar and go all the way to the right, it's under there, under Visual Programming. And if you select the Dynamo itself, it will open up a new window still within Revit that's basically the home button. So your new open all your recent files, and then some introductory links both to actual scripts, and this Dynamo primer is really good in case you got a question or wonder where certain things are. Obviously video tutorials, YouTube is also a good place to start, but we're just going to start with a new script. It'll open up to this page, and then on the left-hand side is all of your different tools. So in Grasshopper, they're all located at the top. Dynamo, they're on the left. And they're all broken into groups. So mainly, we'll probably be focusing on geometry the most today. And then Revit is where you get all your Revit elements and tie that back in. Simple math functions, etc. And then at the bottom is where you have a lot of plugins or add-ins, just like Honeybee, Ladybug, Lunchbox, Kangaroo are for Grasshopper. They'll go there, and I'll get into that a little bit later. And then within the basic home, basic field of operation for all of your nodes, there's two different fields essentially. One is or workspaces, not fields. One is where you'll have all your nodes and actually build the script and be able to manipulate the different wires and join all the different nodes together. The other is Workspace, that mimics the three-dimensional field of whatever you're creating. Now that field ties back to Revit. So this origin point here, if you go to the top right, there's two different buttons. One is what visualizes a series of nodes connected, which is your script workspace, and then this one is more of your 3D objects. That's your 3D space. So if you select the 3D, then you can pan around holding the right mouse button, hold and pan. If you hold the scroll button, you can pan around, zoom in and out. And this origin point, this XYZ origin point, corresponds to, if you go back to your Revit project and go to your hidden, it corresponds to the origin point or the project base point of your Revit project. So once we start building objects and relating objects back to our actual Revit project, it's all going to be based upon its relationship to this origin point. So just be aware of that. And once we start building the script, it'll become a lot more apparent on how these two workspaces are used. So we'll just start off with a really basic function. XYZ will build a point. So if you type in point to the search bar, by coordinates is what we want. And with Dynamo, when you search, and if you search manually through the different groups, it'll pop up with the different tools and nodes, and it'll give you a little preview of what it actually does, and then the different inputs and outputs for that component. So this one is asking for an XYZ input, and its output is going to be a point, which is what we want. So we'll select that, bring that in. And then one nice thing that's new with Dynamo that wasn't always around is you can actually manipulate points in different geometry if the element doesn't have specific inputs. So for example, like this doesn't have any specific inputs for its XYZ. So we can actually go in, if we go to the 3D workspace, we can actually go in and manipulate its XYZ coordinates manually. And then if we go back to the what's called the graph view navigation, you can see that number sliders have popped up with the corresponding numbers that we manually moved the point to. And then you can go through just like a number slider in Grasshopper, you can move them and it will move the point. Now, all of these things, the XYZ toggles, those stay, but let's say we delete this number slider and instead go in and just type in number, get a number input. This is asking just for a general number within 3 decimal points, so we can just say 10 or 15, whatever. If we plug that into the point, now that's telling us, or telling the script that the x component, the x coordinate of this point is always going to be 15, and so it removes the ability to manually toggle that point and only allows us to alter the y and z coordinate. So just something to be aware of. Also, for whatever reason, Dynamo does distinguish integers from number sliders. So integers, whole numbers, number sliders have a series of decimal points. So if you select the integer slider, just be aware that there's a difference between the number and the integer slider. And then within the sliders, if you hit this drop down arrow, you can specify the minimum and max and the step count for each. So if we plug that in, oops. It also, as you can see, it still doesn't allow us to manually manipulate the x coordinate of the point, and that's because they're integers and they're whole numbers, so we technically can't go in between a whole number. Adds a little bit of control. So that is the basic points and some basics into the geometry and the differences between the node workspace and the three-dimensional workspace. One thing I did forget to mention, down at the bottom left is allows you the ability to either manually run your script or have it automatically live update. So if we change it to manual, it's going to allow us to click this run button. So we can change a bunch of things in our script. Let's say we just toggle a bunch of the sliders. We have to then hit run, so it'll then live update. Of course, I toggled it outside of the field of view. This is really good if you have a really complex script that takes a lot of computing power to crunch through. So just be aware of that. If you do have, if your script does start to become really complex, and bogs down your machine, just switch it over to the manual and work on your script that way, and then just hit run. I did that when I was developing my my thesis. I would do whatever I needed to do, hit run, walk away from the computer. 20 minutes later, it would finish computing. So we'll get this back down into the field of view. This is probably way too high from a min-max standpoint, so we'll just tone it down. And then what we're going to do is we are going to copy paste this. And we are going to manipulate a couple of the sliders so that the 2 points are away from each other. Let's pan around and see. Let's put one of the Z's at 0. It doesn't really matter. So what we're going to do is we're going to create a cube. Or actually, first we're going to do a line. Sorry. So let's type in line to the search bar and select the first one by start point, end point. That's asking for a start point, asking for an end point, and the output will be a line. So we can just plug those guys in. Real basic stuff, nothing too complex. And we can manually toggle this so they're a little bit farther apart. And then one thing I wanted to point out at this point is what's happening within Revit. So if I split screen the window with Revit, you can see that within the Revit environment, let me just close out because I don't need these two. Within the Revit environment, this geometry is being previewed, but you can't do anything with it. You can only do something with the geometry you create in Dynamo if you apply that geometry to a specific Revit element. And I'll give you an example of that. So typically, the majority of things that you're going to be inputting into Revit are three-dimensional geometry from Dynamo. And so with this line, we can build a cube. Actually, with the points, we can build a cube. Actually, let's manually toggle to it. So if we're just starting off at the base search function, we'll go to geometry and then solids, cuboid, and then we can select by corners. This is asking for a low and high point, so we can use our original points as the 2 points. That allows us to create this weird little cube. Can stretch probably this one out a little bit more. All right, so we've created the 3D geometry, as you can see from our 3D window, but we still can't manipulate it or do anything with it within the Revit project, and that's because it's still Dynamo geometry. It has not been applied to or applied to a specific Revit geometry. Revit needs to know what specific Revit element it actually is, whether it's a conceptual mass or a generic model or an instance. It needs to know that before you can actually import it into the Revit workspace and manipulate it and work on it from there. So what we're going to do is we're going to type in geometry and then instance. This is one of the things that I hate about Dynamo is its terrible search function. If you don't get the specific things, there we go. Import instance by geometry. So by geometry, import instance. So what this node is asking for is Dynamo geometry as its import, and then as its export or output, as its input and output, it's asking for it's going to output, excuse me, an import instance. So this would essentially act just like if we imported an AutoCAD file into the Revit environment. This would be the exact same type of element. So if we plug this guy in, then you can see that it's turned from the weird nondescript blue to an actual black and white outline that you can actually select. If you do try and drag it, it's still tied to the Dynamo script, so it's still tied to those input coordinates from those 2 points, so it's always going to go back and tie to that. However, if you close Dynamo and you save your script as where is the university? So if you save your script as class project or whatever it is. Now that you've closed Dynamo and it's lost its live link to the script, you can then go around and manipulate it however you want. Now you can see that the preview geometry is still there, but you can actually move the physical geometry around, and you can do everything that you would be able to do with an import instance. If we turn the properties back on, you can tell it's an import symbol. It's got this weird funky name. It has an associated level to it. It has an offset to it. But if we went back in and turned Dynamo back on and open that same script, it's going to tie directly back to it. Just be aware of that. Once you have that script open, it's always going to link back whatever geometry you've imported into the Revit environment. It's going to go back to whatever geometry and information is driving that specific Revit element. So we've done a bunch of how to generate geometry within Dynamo and import it into the Revit environment. Now let's take something we've created from the Revit environment, import it into the Dynamo environment, and start to manipulate it from there. So before we get into all of that, I want to point out plugins and what the plugins are and where they're found typically are under packages. So if you go up to the top, go under package and search for package, this is going to bring up every single add-in and plugin that you can import and download into your Dynamo environment that will help you. They're either new nodes or better nodes or mini scripts. And for what we're going to be using today, we're going to be using Lunchbox. Now, Lunchbox is really good. It has a bunch of panelization and just a lot of nodes that they've kind of taken from Dynamo, and what's lacking in the base Dynamo node, they've improved upon. So if you type in Lunchbox and then select the first one that pops up, it'll give you all of the different versions that they've created, and you can go in and install that onto your Dynamo. However, and it seems to be some sort of issue with Autodesk and their package manager, they have Lunchbox itself has moved to a out of software downloader and installer. So this is how you would normally do it. And if you want to go in and search for, paneling tools, or if you Google, a specific package and it's found on here, this is how you would do it. You would go in, type it, search for it, open this web page, and then just install it. And then really it's pretty simple. It installs right on your computer. It'll pop up down here, and then you'll be able to toggle whatever you've downloaded. Now, for Lunchbox, which we are going to be using, you have to download the second to most recent version, the 2018.7.7. The 2018.8.8 literally just tells you that they've moved to an off Dynamo location. This is just another example of why you shouldn't use Dynamo, is because a lot of the developers are giving up on it since it looks like Grasshopper will be integrated pretty soon. So when you have that installed, all you gotta do, close out, reopen it. It should populate on the left, and then if you do the drop down, then you can see all the new tools that you can select from and do cool stuff with, which I will show you right now. So getting back to the original point, sorry, I just spent like 20 minutes trying to search for different versions of that. So the original point to this was to create some geometry in Revit and import it into the Dynamo environment and manipulate it. So toggle back to your Revit file and go to conceptual massing. Let's do an in-place mass. Doesn't matter what it's called. And then all we're going to do, create a let's create a circle on the level 1. Let's change the placement plane to level 2. Do one above it, and then do one at the roof level, a different size. Kind of make it a little funky, a little out of the way. Select all 3, create form, create a weird little oblong shape, and then finish the mass. And then create some mass floors for all of the levels. All right. And then what you're going to do is go back to your Dynamo environment, select what you created already, right click, and hide all geometry preview. That'll turn that off for the moment. And then what I'd like you to do is type in select face. So we're going to essentially select every one of the, well, at least to start off with, we'll select the bottom mass floor. So hit select on your node, select, and then go in and select the first mass. And then if you go to your 3D workspace view, you can see that it brings in that face into the Dynamo environment. And you can do that for the other 3 mass floors. So all you got to do is hit change, tab in, grab the next one, and then do the same thing for, not the side, not yet at least, for the top. Okay? So we have our 3 faces. So what we're doing is we're going to take these mass floors, we're going to find the edge curve for each of them, and then what we're going to do is divide that perimeter by a certain amount of points, connect those points, and create a triangulated diagrid structure of lines that we can then associate structural columns to, Revit columns to, that we can then import back into the Revit geometry and use, and essentially create a parametric, what am I trying to say? A parametric structural system. So we have our first face that we want to divide. So we need to go in and find that perimeter curve. So what we can do is just type in perimeter and go down to the perimeter curves. This is essentially asking for a surface, and it's going to output a curve. So if we do that, plug that in, now we have the curve. Now the thing with especially circles, which you've probably figured out as you've been working in the Revit environment, is any circle, any kind of curvature, closed curvature, is typically going to be broken into 2 curves. And as you can see, if you hover over the node and then go down to this little tab that pops up, if if you hit that pin, it'll lock it in place, and then it'll show you all of the outputs for that node. And what it's giving us is essentially two curves, right? It's giving us one curve, and you can see it on the geometry itself. One curve is this half, and then it splits, and the curve on the other half. So what we want to do, and to make this a little simpler, I've tried doing both, but it sucks. It just gets really messy. So what we're going to do is we're going to isolate one of the curves, and then we're going to isolate the curve on the next corresponding floor, and then we're going to divide those and connect them. So what we first need to do is flatten the list. What that does, if we look at these two lists together, and if you're familiar with Grasshopper, list structures are very important within scripting. So this is giving us essentially a sublist of our two curves. What the flatten does is it gets rid of that initial list and allows us to select a specific item. So let us get item at index. So this is going to take that list of curves, and then it's going to ask us for the index, which is this number here, either 0 or 1. So we want a number 0. So now this is just, and you can see in the preview, it's highlighting one of the curves. So then what we want to do is we want to apply this same line of script, copy and paste it, and apply the next corresponding mask floor to it. And kind of space this down a little bit. All right, so we want to make sure that, and of course, the two curves are not on top of each other. So we need to change this from 0 to 1. And you can use an integer slider if you want. You can do whatever, but we want to make sure that this recording perfect. All right, sorry, my computer almost died. I'll have to edit that out. But where was I? So now the two curves are right above each other, so we can now go in and divide them. And I'm going to maximize this so it's a little bit easier, and you can see the 3D view. So this is where we'll start to use Lunchbox. And I'm going to type in divide, and then Lunchbox has a really nice divide curve tool. Dynamo does have one, but it's kind of sucky, to be completely honest. So we'll do that, and then an integer slider. Make this 10. All All right, so now we have 10. So let's change the max to 10 and then put this down to 5. So now we have 5 divisions of this line. It gives us the points, tangent planes, different parameters, which is very useful. Do the same thing to the curve above. And then what we can do is type in line, do by start endpoint, plug the 2 points in. Now we have a nice little substructure. So we're going to shift. So if I want to triangulate this guy, what I need to do is basically connect this point to that point, that point to that point, so on and so forth. And I can do that a couple ways. I can use a shift indices, which is essentially saying that I'm going to take a list, so this list of points, and I'm going to shift it in its current state one, so that basically the first item becomes the last item, the second item becomes the first, the third item becomes the second, and so on and so forth. So if I copy and paste this number, tell it to shift 1, and then plug that into the endpoint. Actually, excuse me, let me copy and paste this so we maintain the original. Now that does that. The problem is this guy. So it takes this and this point, shifts it to here, but then the next point, it takes this point, connects it to the next point in the other list. So what we need to do is essentially remove this this guy, this line, within the list structure. And to do so, instead of shifting the list in its entirety, what we're going to do is essentially just remove the first point in this list. So then the first point in this list automatically goes to the second point in this list, and then so on and so forth. For those of you not as familiar with scripting, it's probably a little bit confusing. If anybody wants to review it or go a little bit more in depth, you can. But this is relatively simple stuff within the scripting environment. So we're taking the first item in this list, which we want to copy and paste the 0 into the indice. What this does, if we look at these two lists. If you do the dropdown on this one, since there are 4 outputs to this node, it gives you 4 different lists of data. So this is giving us 6 points in this list from 0 to 5. This is only giving us 5 points from 0 to 4. And that means that it's removed the first number in this list. So if we look at the list on the left, the first number is negative 63.56, at least the X value. And you can see that this remove item at index, it has removed that first item. So within this node, it is telling it to remove the 0 indice, or the first item, 0 indice of the input list. So it removes it and leaves the 5 remaining points. And when we plug that into our start point endpoint, you can see that it creates a nice regulated, triangulated structure. All right, so then all we got to do for the remaining structure is to plug these guys into the last remaining mass floor, top floor. We can probably unpin those data structures, data lists, plug the surface into there, and then What we want to do first, to make sure we're not confusing ourselves, we're just going to plug in the 2 points really simply. Aha! And now what do we have? So what we have here is essentially the curve on the top and the curve on the bottom. Its start and end points are different. So what I would imagine, let's say the start point of this curve is on this side and the start point of this curve is on this side. So the first point in this subdivided list is over here, but the first point of this subdivided curve is over here. And so it's connecting the first to first, second to second, third to third, etc. So what you need to do is reverse those points. You can either reverse the curve, the direction of the curve, which is this guy right here. If you plug that into the curve, it'll switch it. You can also reverse the list. So this is a reverse lift function. And if we plug that in, then it's going to do the opposite. But if we unplugged the reverse curve, it does the same thing. You're essentially trying to just reverse the order of the curve, whether that be in list structure or actually reversing the direction of the curve itself. So now that we have our base lines, what we got to do is go back in, do the same thing we did here by removing the first point of one of the point lists, which we'll do. Do we want to do it to the same? Yeah, we'll do it to the same curve. So we'll do it to the same one. So essentially all we'll have to do, since this is still plugged into the remove item, all we got to do is take the divided curve of the top mass, plug that in where the bottom mass was. Boom. We have a nice triangulated structure. Now, if you'd like, you can go in, do it to the opposite side of the form. All you'd have to do is go in and essentially, instead of finding it within this component, instead of finding this curve, you would identify and select the opposite curve of each one, and then do the same exact process that we just did. Now, what do you do with this? Well, you can use these curves to create structural components within the Revit environment. So what you can do, since these are relatively vertical, they'll be angled columns, probably more referred to as beams, but we can just say column. And what we can do is down at the bottom, or in the middle, I guess, is column by curve. So it's creating a column based on a curve Dynamo component. So if we select that, it's going to ask for a curve, which is fine. But it's also asking for a couple other inputs directly from Revit. So we can plug the curve component, our lines, into there. And then it's asking for a level in which the columns are associated to. And what you can do is just type in level to the search bar. The first one brings up levels, and this allows you to select any level within your Revit project. You can select here. So select level 1, since this is the bottom. Select level 1, and then the last thing it's asking for is a structural column type. So what it's asking for is essentially, what column do you want to apply? Do you want a round column? Do you want a square column? Do you want an I-beam? Do you want a C-channel? So typically the input name will match the name of the component. So if you type in structural column type, select that, then you can, sorry, no, wrong one. Structural column types, there we go. So structural column types, and then you can select pretty much every column, which in this project specifically it's only 2, but if you load in let's say a round column, like you did for the Villa Savoy. Oh, how do you pronounce it? Savoy. Villa Savoy. If you import that column, which let's just do that really quick, insert load family, and then wherever you originally saved that file, documents, where's my column? There it is. So I've loaded that in. Now if I go back to Dynamo, it should, there it is. This is the HSS, so these are the two hollow round columns. So we'll just do 10-inch for right now. Plug that in, give it a second. And if you go to your Revit environment, see them plugged in, and then they're kind of bulky right now, so what I'm going to do is just, you shouldn't do this in real life because obviously structural beams, their naming conventions tie back to their size, but just for aesthetic sake right now I'm going to change that, and then go back to your Revit or your Dynamo environment, and you can just copy and paste this guy down. Actually, let's see if you can add multiple. Guess not. What is this? The end of the curve. Oops. The end of the curve for creating a column should be above the start of the curve. Alright, so this is essentially asking us. Oh, it's because the level, maybe the level. So these lines should be hosted to level 2. So let's change these to level 2. And then I also believe that we just need to switch the start and end point of these lines. So if we go in, take this one, plug into the start, plug this one, plug it into the end. There we go, and then copy paste and plug this one in, and then we might have to do the same thing. Yeah, that's alright. So if we minimize this, go into our Revit project, you can see now we have a nice old set of columns that are triangulated. I guess they're diamond shape, but realistically you would have a horizontal beam connecting those as a diaphragm. But for right now, we'll just keep it simple. So for this assignment, or for the attendance, I guess, what you can do is just submit this. An image can be a screenshot just of your structural system. Feel free to complete the other side if you'd like. And then the homework assignment will be getting into